Right. Again, we have packed things today. So the next panel to my audible colleague here, and then it's about research. And if I just kind of a little bit. So we talk about agentic AI mitigations and all that. Sometimes people read it and they think, my goodness, what's all this? And we want to understand how does the research can help with all this. So over to you. Yeah.
All right, so where are my panelists? Come over here.
Oh, okay, so you may have, sorry about this, but you may see a discrepancy. Come here, do you look like this? No, you don't. So we had the substitute from, instead of Will, we have Darren.
Full of surprises. All right, so I know a part of you are more into the governance and that's what you're doing on your daily job, but the other half is probably more about going with your hands and researching for threats, and that's why we wanted to bring the best of both worlds. So moving forward to our next panel, please, let's start with the introductions.
Good afternoon, everyone. I'm Paul Miller. I'm a professor in AI security at Queen University in Belfast. I'm also Deputy Director, actually, of the Centre for Secure Information Technologies, which is the UK National Innovation Centre in cybersecurity.
Hey everybody, Darren Lewis rather than Will Gurney. So I am from Plexel though, so Plexel Innovation Growth Company, and we work primarily with government. In particular, I'm working on the Laboratory for AI Security Research, which actually I've spoken to both these guys about, and also some of the other panelists that we've already just had.
Cool. Thank you for coming today. Hi all. I'm Alan I'm with the Alan Turing Institute. I lead the team on AI for cyber defense. We work with national intelligence and also AI vendors. We are hunting for new, paradigms and just like use cases that will drastically change our cyber defense capabilities.
All right, thank you. So before we dive deeper into AI security research and how the entire landscape shifts from researching traditional threats to AI security, I want you to please share with our audience how the security research at the UK works, because when I first found out about the huge collaboration and this movement that UK builds, I was super surprised for the good. So I want to share this information with you.
Right. Do I go first? Yeah. So I guess it differs. So the Turing is not entirely industry, somewhere between academia and industry. So I guess we'll get kind of the whole spectrum here. So for us, we don't necessarily seek to commercialize or go all the way to use cases where you provide even tech support, but instead we seem to unlock, we want to unlock capabilities that AI makes possible. So we do try various things, see what AI is capable of doing, how far it can take us, and then provide the kind of a framework and open source tools that people can use.
So I'll talk from the guys of LASR, I guess, and the government initiative. So yeah, we work across the spectrum. So we're very interested in very early core research, so very early TRL, and we take that all the way through to how we can commercialize that. So my angle is more on the commercialization and the innovation side. So what's going to make people adopt the research that takes place? How do you get from that chasm of early research to actually deploying and making a difference? And how do you prove that? And some of that was just discussed in the last panel. And also, how do you make commercial use of that? So how do you generate the IP and then commercially create something tangible that you can then license, you could then use, spin out to then regenerate the revenue to then create the research again. So it's sort of continuous cycle. So that's how we work, and I guess within LASR, we both work directly with Queen's University, so we'll talk about that. We work with University of Oxford, and then with Alan Turing as well. We do the sort of the further reach out to all the other different university and academic institutions across the UK. So a broad breadth of all of these different things brought together in sort of one core initiative.
Yeah, so at CSIT, we've established a thing called the Cyber AI Hub, and this is really looking at research and innovation at the intersection of cybersecurity and artificial intelligence. It mainly started off primarily about how you apply AI to different cybersecurity problems, malware detection, network intrusion detection, website penetration testing, but it's evolved into the security of AI itself. What we do is we work with a hub of companies, around about 8 or 9 companies, ranging from startups to SMEs to multinationals. And we also have an engineering team, which is quite unique for a university. So we can take products, research up higher TRL levels to 6 or 7. So we can really de-risk the whole thing for companies trying to go to market. So some of basically what happens is the companies come to us, they define their challenges, and then we put a team around them. So we may have AI people, we may have cybersecurity people, but having both of those things together is really important. So it is. And then we'll put in some engineers and maybe a postdoc that will work with the company to try and develop a new product or service. So we're talking about security operations centers. So one of the projects we're working on is the development of a co-pilot for security analysts all around software vulnerability detection and automated patching. So a wide range of projects. In addition to that, then you have to really populate that ecosystem that you're trying to grow with people. So related to that, we have a doctoral training program, and we also fund master's students. So we have 2 masters at Queen's in applied cybersecurity and AI. And so really trying to create an innovation network amongst the students and the companies to help grow or scale that system.
I think that's super, for me, inspiring to see how different organizations collaborate together. So that's, first of all, a good lesson for all of us. And, for me, the hardest or the most challenging yet fun challenge, moving from traditional security research into AI security research, and particularly the agentic security research, is that you don't know what to expect, right? Like, it's not determinist. So you can plan a research, but at the end, the result will be different, or it's very hard to repeat the research many times while you get different results every time. And obviously, the 3 of you has lots of experience in security research in the traditional domains. And I wonder, what is the most challenging shift that you've done?
Okay, so I think security is something that can be abstracted. It doesn't really matter what the medium is. Is it physical? Is it cyber? Is it social? The core sort of tenets of security, confidentiality, integrity, and availability, all relevant to AI security, basically. I was a member of the ETSI formed a group, Industrial Advisory Group on Security of AI, which is a precursor to their standards group at the minute. And the first document we wrote was the problem definition. And effectively what we did, we applied a security by design approach to the machine learning pipeline. So for each part of that pipeline, we identified confidentiality, integrity, and availability issues associated with that. So it's really a secure by design approach. Other principles, for example, least privilege is a security principle. So we developed a new learning algorithm called least privilege learning. So this ensures that whilst it's learning the task it's supposed to learn, it's not learning other things. So it's not, okay. If you look at something like federated learning, that's really employing things like separation of duties. So we call that separation of learning. So for me, a lot of the basic security tenets and principles can be equally applied to AI. You get different issues. So when we did the design, security by design approach on the machine learning pipeline, some of the security issues were just generic cybersecurity issues. AI is a program, it's a software, there are vulnerabilities in that software. But there are other things related to things like training and deployment that presented unique security problems, basically, that came out of that. But fundamentally, people should be applying, and this is really important, we need both cybersecurity and we need AI, people working together.
Yeah, thank you. So I think what's different from traditional security auditing with agents, at least, is it was touched on in the previous one, already mentioned on this one. I think the point has been made several times, is the non-determinism. it's not that something we haven't seen ever in security, but it was in a pretty specific context. It usually having to do with cryptography and pseudo random number generation. That is supposed to be deterministic, but you may collect noise from the environment, and gauging how random something is usually hard. But outside of that, I don't think security is used to kind of non-determinism, and it is a problem because we usually do audits by looking through configuration files or source code, and that is pretty static. When you try to audit agents, things change, and I think we start to see works that try to kind of nail down the agents and the sources of randomness, but it's not that simple, especially when you have like optimization, inference optimization on the way, or things are split across multiple nodes and GPUs. You start to get noise in the whole process. I don't have a solution to that, unfortunately, if that's what you expected me to say. Well, I think it's part of the problem we're facing right now, which is, well, yeah, sure, but we haven't been able so far to audit humans, and I don't think we'll be able to audit agents in the same way we audit code and like infrastructure. But maybe that's fine. Maybe we'll find another way that is good enough. I think security does quite a lot of things that are good enough. So maybe that's the way forward.
Thanks. So I don't specifically do research myself, but yeah, I guess just flagging what maybe the panel previously said as well. I think there's a lot of emphasis on the technical research that happens, obviously, and necessarily. But I think there's a lot of ambiguity or lack of engagement, maybe, by other people within the academic sphere, where they have to, again, it's an educational piece around AI. Everybody needs to know about AI. So we touched upon some of the psychology. I think, Ali, you mentioned that actually when you're making decisions within an organization, yes, it needs a technical team, but you need the operational team. You need some high exec oversight of that. Sometimes you need regulatory, sometimes you need legal. You need all of those different components. So for me, yes, technical research, there's lots of different additional challenges for the reasons these guys are saying. But I think there's definitely a scope for broadening that piece out and thinking of research in a broader perspective.
All right, that makes sense. So how do you even choose where to start? Like, what do you have to research? For me, it's quite easy because, I'm working at a company that protects enterprises that's using like the enterprises applications, but for you it's more wide because what are, individual humans are doing, what is the government doing? And I'm really curious to hear how can you prioritize what you research when every day a new feature comes out, a new application is being adopted, and it's hard to keep up.
Yes, it's a really good question. And so from LASR's perspective, what we've got is something called, there's two sort of assets. One we call the problem book, one we call the opportunity book. Problem book is looking at DRL level research. And really it's looking at, so across LASR, we look at government own use cases, and we look at particularly sort of CNI, critical national infrastructure sector use cases, and where the two cross. Where we've got to so the problem book is almost defined by some of the use cases that we have from given to us by different government departments. So that's a sort of an aggregation of all those different departments. But really, it's a case of, for the critical national infrastructure piece, we need to get a broad perspective from lots of different sectors. So yes, the finance sector, the health sector, energy, water, all of these different component parts. And so we've ended up running a series of workshops and initiatives to try and collate all of those needs. We combine that with secondary research into OWASP, we use, of course, NIST, others, to then confine that down and refine it down so that we're working on things that, yes, at the forefront of technical research, but also they matter. We can see an end application. That's not always the case, of course, with early TRL research. You don't always see the end in sight, but actually we're trying to sort of come at it from both ends and try and solve that problem by addressing both and meeting in the middle.
Thanks. No, I actually totally agree that it probably needs to be use case based, in particular, because I don't think there is a single intervention that we can, once we discover, invent, we can apply it everywhere across the board and make everything safer. Having said that, I think part of the academia is still hoping for that kind of silver bullet. And maybe if some of you were more familiar with the kind of robustness line of work on against adversarial examples, there is a part of the academia working with all those kind of adversarial examples and training against them and coming up with elbows and that are meant to make kind of classifiers bulletproof to adversarial examples. And then there's always kind of this one up, someone coming up with an attack and then improving the defense. And in the end, I think this is never going to pan out. That's my personal opinion. Some people obviously hope that at some point in the end, defense wins. But from what we've seen in security, is probably a kind of a net or a combination of interventions that make things secure. So defense in depth, I suppose. For example, prior to AI, in the binary exploitation era, we didn't escape that by inventing one technique that made binary exploitation impossible. We had dress randomization, stack canaries, a bunch of things that individually they were all quite possible, but all together they make it so hard for an adversary that, you know, attacks are becoming, there is a lot of friction if you want to come up with an attack, and even like trialing a system and figuring out how to exploit it, even if there is a vulnerability, it's becoming very hard. I think the same principle will probably apply to kind of AI deployed in specific use cases. So, yeah, that AI will be fundamentally vulnerable in some ways, but you can have a bunch of countermeasures or mitigations or defenses deployed that to the point that actually, if you sought to attack that, it's not straightforward at all.
So as an academic, the main way we keep up to date is obviously to read the literature. So that's one mechanism. But also, like I said, we work with companies. We do a lot of work with companies, and they bring exciting challenges and new problems to us. So one of the projects we're working on at the minute is from a multinational company who do a lot of work in safety critical systems. And if you work in that field, you have to do what's called, you have to build an assurance case for the system. So if you think about a safety critical system that has software, that software has to be certified. So they want to now introduce AI into their safety critical systems, which means the AI model has to be certified. And in order to do that, you need to build an assurance case for that AI model. So what we've been working on is developing an assurance case framework. It's a cycle framework that basically tries to develop an assurance case for the AI model that's going to be part of that system. So that's something I have no idea about really. You know, so again, that's coming from working with industries for this. So.
Yeah, sure.
I forgot to do a quick plug actually. So for LASR, our opportunity book has narrowed it down to our two focus areas at the moment are agentic and supply chain, AI supply chain risk and analysis. So we've just completed a program on agentic, and the results will be out soon actually, but we've got an open call on the supply chain work. So if you're working on supply chain solutions, AI supply chain solutions, that's either at the edge, SLMs, restricted sort of compute areas, component provenance, or sort of, I guess, drift of solutions, then please let me know. Or go to later.
That is an academic institutions industry collaboration live. All right, so you know when you do research or you heavily exposed to research, particularly in AI and agentic AI, I feel like on a daily basis there are like shocking, surprising evidence that you know they caught you surprised each and every time. And I can give an example. So I'm going to spoil a bit, but one of the latest research that my team worked on, and I won't spoil all the details, but is how just the simple tooling functionality at one of the biggest vendors, which I won't say the name, but Mario will know. Yeah. just implemented their tool action. So without even like LLM manipulations, you can easily exploit data and you can easily do a workflow hijacking without even manipulating the LLM. So that for me was shocking how easy it is. And I'm curious to hear what was the most shocking, surprising evidence that you found lately or you heard about lately.
I'll use one that's directly that we've just done on. We created some test harness for AI solutions, and yeah, we worked with a company called Fuzzy Labs up in Manchester. We created a test harness that took known threats to, on this one, it was around guardrails, prompt injection. And we took libraries of known threats and created scripts to basically test the model. And through doing that, we found that the majority of solutions that were publicly available, open source solutions, were about 50%, like solving about 50% of the threats, actually catching about 50%, literally just 50%. So if people are absorbing these things and actually, again, not testing them thoroughly, then yeah, be aware, because that was a lot scarier than I thought.
Let me ask you a follow-up question. That's very interesting. To what extent was this 50% kind of perfectly overlapping, or could you combine multiple solutions to go beyond that?
Well, that's a really good question, which I don't have the definitive answer to. I believe there was again the Venn diagram of the 50% were quite overlapping, but there's quite a big fringe of others that were not the common ones. So yeah, I won't name names, but
Yeah, so I'm not that sure my research is that interesting, but something that really does interest me is the emergent reasoning of large language models. It's pretty amazing, so it is. So things like chain of thought, that type of stuff, and I think there's a lot of research to be done. The jury's out as to whether this is really reasoning or it's just pattern recognition from its training set. But also then I saw a recent paper on an attack on reasoning, if you like, of a large language model called I think it was DarkMind. So you can customize an LLM by having a set of instructions that will follow the prompt. And so in DarkMind, they attacked those set of instructions. So they injected rogue instructions that would disrupt the chain of thought process in the large language model. So yeah, that's something that's of interest.
Very interesting work. So we something we did recently was publish this paper with Anthropic and the AI Security Institute, where we looked into basically training dataset poisoning and found out that actually one common assumption, and I have to admit I assumed the same thing, was that the largest the model and the largest the training dataset becomes, if you want to poison this model to introduce a bug or some malicious behavior in there, you need to poison a largest not percentage, but the number of samples you need to poison grows proportionally. But we found out that's actually not true. So you need to poison about 250 documents, which is like every document is not that many pages long. And that's all you need, regardless of the size of the data set, which was surprising and a bit concerning. Yeah, I have to say though that kind of having this knowledge by itself, unless you do something about it, doesn't necessarily improve security directly, but being aware of this is already kind of a good step.
Wow, thank you for sharing. And you will bring up some interesting evidences, but I think that you really match the expectations. All right, so with that, I want to move on and talk about, yeah, we got a question. All right, go on.
So most of you are into academia and intersection of it. We talked about AI security research. What's your views on AI being used to do AI security research?
That's an interesting one. I must admit, I haven't planned that, so thank you.
Okay, I can take that and then.
Can you repeat the question?
Yes. So and correct me if I'm wrong. My understanding is can we use AI to do part of our job? So AI security research.
No, it
Nope.
wasn't that. You want?
What's your views on AI being used to do AI security research? Like we are using AI for pen testing and a couple of other security stuff. So now how about AI agents start doing AI security research?
Yeah, that's.
Yes, using AI to do AI security research. I think it's going well, but the progress is not very symmetric in the sense that AI is really good in finding vulnerabilities given the source code, or at least decent. I think in black box systems, which part of security work it includes, at least pen testing, it often is the case. We don't know that much there. I know people are benchmarking using capture the flag competitions, but this is a bit not a clear signal to me because there are lots of write-ups online, and it's not always the case that, you know, capture the flag challenges are not derivative of each other. So it's often that the agent has seen something or the model has seen something similar during training, and now you're giving it something that you think is new, but actually it's not that new. Things are getting better, but it's not there yet. Yeah, that's my kind of thing.
So do you mean using AI to do AI security, or do you mean AI to do AI security research?
Research, write papers and publish and everything.
So I don't think really AI is at the level where it can do research. It would be my answer to that. I don't think that's been demonstrated. But my understanding is that the sort of level of intelligence, I feel like, is around about master's level. But I don't know whether or not it can. I mean, it's going to be defined by its training data set, basically. So whatever it's trained on. So I think there's lots of evidence to show that, you know, agents and stuff like that there, if or large language models, if you give it a problem that wasn't covered by its training data set, it doesn't perform that well. So that would be my view on it.
Can I add there?
All right.
Very
Yeah.
quickly, I said the progress in that space is asymmetric. One side is you have tasks where the model can see the source code, and I think there's like where we see most progress. On the other side, you have cryptography, algebra, stuff like this. I don't think it's doing great there, except for things that require just reasoning. It's more abstract math, but yeah, these are the two sides of the spectrum, in my opinion.
All right. Yeah, John. So I want to move to talk about a framework that I'm not sure if any of you heard about, the Agentic Top 10. And I want to ask you a question because I feel like there are lots of research about prompt injection, jailbreak, trying to manipulate LLM to do unintended behavior, you know, in the conversation with the user. But there's less conversation and research about issues such as identity management, the tool poisoning, the context injection being quite hyped for a while, but now it's like a bit low again. And the inter-agentic communication, I feel like these are less, you know, heard lately. And I wonder what is your opinion about it? Why researchers are going straight forward to those prompt injection, jailbreak, and left aside all of these important risks that are none less risky, right?
So I think one of the reasons for that is most of the focus in AI security has been on learning. When you start to talk about agents, you need to think about the security of reasoning, security of planning, the security of adaptation. So these are very, very new and young areas. So for me, again, security of reasoning is going to be a big, the next step in AI is really all around reasoning. Learning's been a lot, you know, done to death, really. So yeah, so I think as that develops, the whole reasoning piece, then security of reasoning and so on will become a bigger thing, basically.
Okay.
There's a time for all of you, don't worry.
I think there is a small bottleneck in terms of we all see the potential, but without concrete use cases, it's often hard to kind of anticipate where the thing is going to go. And, you know, Now the obvious thing is chatbots, so it's kind of more straightforward, and maybe we lack a little bit imagination as well. But at the same time, it's maybe a chicken and egg problem where people don't deploy new use cases because it's not robustly secure, and people don't make it robustly secure because they can't envision those new use cases.
I guess I will just say, against the two sort of laser focus areas, in agentic, they were looking at sort of identity of component parts and memory poisoning. And with supply chain, again, they're looking at that sort of component provenance and drift. And so I think we're seeing people tackle those challenging problems. I think the majority of people, I guess, as Vas said, where you've got a clear use case, it's easy to contextualize the research that you need to do to solve it. Whereas I guess, you know, with the question that was just asked, we get a bit meta and we get a bit more involved. It becomes a bit more difficult to do. But actually, we're definitely seeing people across academic institutions across the UK tackle.
So there's what's to expect in 26, I guess.
Yeah.
All right.
For sure.
All right. So we're now releasing the framework, the Agentic Top 10, and sometimes it can be quite hard for companies or organizations to take that framework and break it down and think of how do I make it actionable or what do I take out of it. And I wanted to ask your advice for our audience on how to do that and how your institutions are planning to do so.
Yeah, so how to engage in it? I guess so. Previous panelists talked about Bridge AI. I think there are. So again, we are looking for a sort of CNI, CTO, CISO, almost panel that we're going to put together so that people can start to learn from each other how they're trying to address these different things. I think it's very difficult for individuals to try and take on board all of this. You know, people again, they're fatigued by the number of changes and things they have to adopt within their organizations. I think there's an opportunity where people collaborate, where we can get people together to actually talk about these things, both individually within sectors, but there's definitely cross-sector learning, like cross-pollination of ideas. And so, yeah, we're looking to form like a board of CNI sector experts to come together. I'll just quickly say, we mentioned the AI code of practice previously. I've done another workshop whereby we looked at that, and again, the education came out as the biggest blocker that everybody across the room unilaterally sort of flagged, or unanimously flagged as the main challenge. So I think it's all about communities like OWASP. I'll call you out. It's about communities working together to try and formulate ideas within sectors, cross-sector, pollinate those ideas, and have a bit of a support network when you're trying to go through the dark times.
Yeah, just quick note on top of everything said already. I don't think the top 10 should become a box ticking exercise. Instead, I think is the right way is kind of it serves as a guide as to the kind of risks that are out there and what if you're deploying something. Think deeply about each one of them, and some of these may not apply to you, right? I, for example, spend most of my time working on the inter-agent communication. If you don't have multiple agents, maybe this is not a massive risk for you. So it's just a sensible guide because the literature is really crazy at the moment. Lots of people are publishing in different directions and different levels of quality, let's say. So this serves kind of as a guide of what is out there, what you need to be aware of and think for your specific use case and what applies to that.
Sorry, one more call out just before I hand to Paul. There's a great paper from the World Economic Forum called AI Balancing Risks and Rewards. I think the University of Oxford GCSEC team wrote that. Definitely worth a look. It will help too.
Yeah, so I guess it really depends on to some degree on the size of the company. Obviously for smaller companies and SMEs and so on, it's a more difficult thing to do. I think Etsy's recently published standards that sort of are a good useful guide to for SMEs, and maybe adopting them to a more agentic type problem is maybe a good starting point.
Okay, that's great. So we're going to enter 26 soon. May I ask just a hint of your research roadmap?
Okay, so again, I talked about assurance frameworks. So we have been mainly focusing on conventional predictive type models, CNNs and so on. So what we are hoping to do is to apply it to a transformer model. So that's one aspect of it. And then also what I said about looking into emergent reasoning of large language models and how we can protect that against attacks.
I don't have a research agenda per se, but so all the components of agentic, supply chain, deep reasoning, folks.
Cool. Not my full research agenda, just a couple of things I'm very interested in. One is because many things in security are dual use, what kind of risks we are facing with AI being misused. And at the same time, certain use cases that are defense only. So if we develop those capabilities, they are actually not dual use. So you're advancing defense only. On that front, we built a sandbox for malware targeting infrastructure, where the model is essentially creating an illusion of infrastructure that's not out there, and we use this to sandbox malware, kind of elicit malicious behavior if it's there, and classify binaries.
All right, I can share that I'm going to explore all the areas that haven't been explored. So no probe injection and jailbreak for me anymore, but just like supply chain, identity issues, and some of the stuff that haven't been discovered yet. So John says that we have to finish, but one last question to end it up.
It's your day today.
Okay, thank you. No, because I want it to be practical for us, and we spoke a bit about the adoption part, but I think it's really hard for companies to know how to be updated in all the latest research and where to consume that, because there's so many information online, but how do you find the really interesting information that can benefit to you, and how do you stay updated in such evolving, I'd say, market or industry? Your final note, please.
So I guess I'll call out both the DCIT publications and CSC publications. Bodies like, and I will again call out OWASP and NIST as people regularly cite. This says, I feel like if I've checked, all the different things on those sites, I feel like I'm I'm in a good state. So I'd go for those bodies first, and then of course, you've got the individual authorities within each sector.
Not really to add there, to be honest. Academics are it's difficult to really know. Like I said, there's various standards coming, emerging, Etsy and so on, as Dan says. So I guess you've got to read them.
All right.
Okay, very quick note. I think common sense goes a long way. So you don't necessarily need all the time to know what's the latest paper and something. So top 10 in that case is good. I think it covers all bases. But tracking the literature through Google Scholar, kind of top institutions, is a way. It's just very time consuming. Sometimes you find someone who does this for you. And you to follow them instead.
Well, thank you so much. I think those are great takeaways, and I hope it will help you out. So thank you.